back in every single chapter. And the beauty of graphical transformations is patterns, right? You know what AH and K do for one function. You can apply it to a sinusoidal or a log function. It'll do the same thing. We also refer to this as HK form. For quadratics, we call it vertex form. I'm going to sketch an XY axis here. We're going to graph a quadratic. Oh, that's bad. Let's try this again. There we go. A little better. Alright, so go ahead and sketch your XY axis. Plot that point. And we did this for 6 functions last class. What do we call this special point? Locator point, right? And for the quadratic, it has a special name. Some of you already said it. Locator point, and we can call it the vertex for the quadratic. I will give you the coordinates for this point. The coordinates are 3, 2. Right? And we'll use this kind of as an example. Now this might sound really strange, but when I was in high school, we didn't have HK form. Which is awful, because you're doing everything by a table. Can you imagine that? Like, even in calc. So I don't know if this is like a new development or what it is, but we finally started looking for patterns, which is what makes math more fun and enjoyable. Here's your HK form, most basic form, and I'll give it to you for a quadratic. Each of those letters does something, and you probably all know what they do. A can also do something else for us. What else can it do? Ernesto.
Determines like if it's facing positive or if it's facing negative.
Yeah, so what is it doing to the graph? What's that verb we can put to it? Flips it. Which way does it flip it? Is it a vertical flip or is it a horizontal flip? Vertical. Have you learned how to flip something horizontally yet? No, not yet. This is a vertical flip. Good. All right, that's my A. Still learning names. Mario. What does my H do? Or Adam. Why did I call it? Oh, because your middle name's Adam, right?
Yeah.
You prefer Adam.
Yeah.
You're like, who's Mario? Adam. What does my H do?
Your H shifts it to the left or to the right.
Okay. Your H shifted to the left or right. We can call this a horizontal shift. But we need to be careful with H. What's going on with H? Becky?
When it's a negative in front of the H, then it moves to the right, and if it's a positive, it moves to the left.
What's a word we can use to describe that negative? Do the opposite. And that's the word I want you to put to it. Some teachers, I don't think Frank does this, but some teachers always teach students, oh, H is the liar. I don't like that language. Because, not for moral reasons, but more so just because students just memorize it's a liar. No, negative, what it means in math is do the opposite. So if you see a negative there, instead of going to the left, you'll actually go to the right. And why this is important, right now the H is negative, right? When you get to a circle, the H and the K are negative. So you do the opposite on both. All right? So if you see that negative, do the opposite. All right. Who can tell me what K does? Sean?
It is the vertical shifter.
Shifter. Yeah. It's the vertical shift. You got it. Up and down. Perfect. is the most basic form. You got it, plus 2. Nohan, which way am I going with the 3? And then with the 2? Go ahead, draw arrows under those transformations. I want you to start getting the habit of just like seeing those numbers and visualizing those shifts. If we go back to our original equation now, or our graph, 3, 2, why is the locator point so important? What does it tell you? How does that connect to this form? What is it? It's your H and K, right? Besides doing the opposite, right? So, for your project that I'm going to launch, if you know your HK, what's the only thing you need to find then? A. Okay? And then you got to start thinking, how am I going to find my A? Okay? Go to the bottom. One other thing I need to give you. It was in your homework. I think it was problem 23. It's the idea of what an argument is. Yeah? So go ahead and write argument on the bottom flap. I'll give you the definition, but then I'll give you some examples that make it a little bit more real. You are cold, okay. Your expression on which the function operates. Okay. Now, to illustrate this, because I don't like this definition, I'll go ahead and give you an example of function, and then I'll write the argument next to it, and all you have to do is look for patterns. And I think you'll see it really quick. Alright. So here's your first one. Alright, I'll let you do the last one. You can probably notice the pattern. And then I want, with your team, for you guys to come up, what's the pattern here? What is the argument? Put it in your own words. Beautiful, 3x. And then, did your team come up with a way of defining this?
It's the portion of the function that contains x.
Okay. Yeah, okay, so x is kind of represented within this. What's another way of saying it? Steven? Yeah, it kind of has to do with the input. That's actually a word we'll write. We can think of this as the input. What's another way of describing it? Nicholas? The parent. What do you mean by that? I like it.
It's like the main part of the equation.
Isn't this kind of like the family? What's the family of this function? What's the family of this function? What's the family of this one? Linear, right? So that's kind of another way of thinking of it. You can also kind of define what the family is. I like that. It's also kind of your quantity that's in parentheses, right? Quantity in parentheses. Now, I want you to look at this a little bit differently.